All right, so Mrs. Erlenbush made a great worksheet. She made a great notes and a great worksheet, and that's what you're going to do today. While you're filling out the notes, I just wanted to just throw in a little, real quick video so that you can just kind of see my point of view on what we're talking about today. As you can see at the top is correlation coefficient. Okay, correlation coefficient is always basically it's also called an R value. Okay, and that's what we have right there, R value, correlation coefficient. Okay, the correlation coefficient is either going to go from +1 to -1. It's not going to be any numbers higher or lower than that. All right, so if you were going to have a scatter plot, okay, and the one data that you would say has a very strong positive correlation would be somebody's arm span in relation to their height. Okay, if now it's not exact, right? But for the most part, the taller you are, the longer your arm span is going to be. Okay, so as height was raising here on the X value, your arm span would raise on the Y value. That's what we call a positive correlation. And those numbers are actually very, very closely related to each other. So that would be a strong positive correlation. Now, if these dots were exactly in line, which is extremely rare, okay, but let's say that I had these dots here and they were exactly in line, boom, right, all the way up, okay, that correlation value, then that would be a correlation value of exactly a +1, okay. Like I said, in real life, that rarely ever happens. In fact, if that happened with an experiment that you did, somebody would probably question your experiment. They'd question your data, and they would double check it for sure, because in real life, it hardly ever happens that there's a correlation of 1, okay? So most of the time, even when it comes to wingspan, yeah, of course, taller people are gonna have a taller wingspan, but there are sometimes when a short person has really long arms, or a tall person has shorter arms, right? So it's not going to be perfect, but overall it's going to be a fairly positive correlation, okay? Another example of positive correlation that I wrote down was ice cream sales to temperature. As the temperature starts to rise, you could expect ice cream sales to start to rise. Another one that, let me see, let me grab my list here. Another very, at least a positive correlation, I don't know if it'd be a strong positive, I think it would be relatively strong positive, would be the number of hours that you do studying math compared to your ACT score. Now at a certain point, at a certain point, it's not gonna stay positive, but for somebody who does no math, their ACT score is definitely gonna be lower. Somebody who does more hours of math, their ACT score is gonna rise. So that's going to be, there's going to be a positive correlation there, whether it's strong positive or weak positive. It kind of depends on the person, okay? So those are some of the things that I've talked about positive correlation. As one value is going up, the other value is going up, okay? So you can see that the data here is pretty tightly bunched together. So I would say that this data probably has a R value of about 0.8. Remember, 1 is as high as it can go. 0.8 is pretty strong though. So that's what we call this a strong positive, okay? A weak positive, okay? I can see the trend that it's going up, but you can definitely tell that the data is getting more cloudy as it goes along. So if somebody came back with a correlation coefficient in their experiment of 0.3, the people looking at the experiment would say, maybe there's a correlation there, but maybe not as well, okay? That's a pretty weak indicator. You really want it to be up around 0.8 or higher in order for you to really feel like you have a strong indicator, okay? Now, if it was cloudy like this, I mean, you know, it's just like a big old, right? You can't tell if that's a positive correlation, negative correlation. Basically, if it's positive correlation, I can draw some sort of line going through it. You can kind of see a positive correlation going like this, right? Well, in this case, I mean, that line can be just about anything. So in that case, that's no correlation, and your R value is really close to 0. All right. So now you can see, okay, well now all of a sudden our correlation coefficient is going, or our line is going downhill. Okay, still kind of a cloudy, but you can, instead of the line being a positive correlation, it starts to become a negative correlation. Okay, and this is a weak negative correlation, about negative 0.3. Okay, so really, the negative is only telling you the slant of the line. Is as x is increasing, y is decreasing. Okay, so what would be a good negative correlation? Well, one thing I thought about is the older you get, the less hair you have. Okay, so that would be negative correlation. Another negative correlation would be number of absences. The more your absences go up, the more your GPA drops. And I think you could show a pretty, for sure that would be a negative correlation. Number of absences that goes up, your GPA is going to drop. Okay. And then the last one that I had, was it's proven that as chickens get older, the age of chickens, the less eggs that they produce, which makes sense. Okay, so those are all things that would be negative correlation. As one variable is increasing, like the age of chickens, then the number of eggs that they produce is decreasing. Okay, so those would all have negative correlation. Okay. So really I've given you enough information for you to fill out the worksheet. You probably didn't even need this video to fill out that worksheet. Mrs. Erlenbush did such a great job. I just want you to fill out the notes, do the worksheet, and then I got 2 more videos coming out on scatter plots, and then probably one more assignment, and we're almost to the end of this thing.